Assalamualaikum and hello everyone. For question 1, model of the molecule ethane C2H6, ethene C2H4 and ethine C2H2. So firstly, I will explain on the model of molecule ethane C2H6. The molecule consists of two sp3 hybrid orbitals formed by the two carbons and 6 hydrogen atoms. The red ball represents the carbon atoms and the blue ball represents the hydrogen atoms. The rotation will occur at the CC sigma bond, this one right here, and produce different conformations. We cannot isolate the pure conformations due to the molecule constantly rotating through all possible conformations. Now, I will show how to use the Newman projection method to illustrate the different conformations of the molecule. As we can see, there are two different conformations that we can obtain, which are ellipse conformation and staggered conformation. When we maintain the aligned structure between the molecule or rotate the carbon atom at the back by 120 degrees, we will get the ellipse conformation. However, when we rotate the carbon at the back by 60 degrees or 180 degrees, we will obtain the staggered conformation. Next, I will explain on the model of ethene C2H4. The molecule consists of two carbons double bonded with each other, as you can see right here. One of the CC bonds results from the overlap of an sp2 hybrid orbital, and the other CC bond is the result from the side-by-side overlap of two p orbitals on each carbon. As we can see from the Newman projection, the carbon molecules cannot be rotated due to the restriction by the double bonds. However, the rotation can occur once the double bond breaks first. Lastly, I will explain on the model of a molecule ethine C2H2. The molecule consists of two carbons bonded by triple bonds, which are a sigma bond at the middle and two pi bonds at the side. The sigma bond resulted from the overlap of sp hybridized orbitals, while both of the pi bond are the result of overlapping p orbitals. As the triple bonds are more stronger than the ethene, so the molecule cannot be rotated as it needs more energy to break the bonds. As for the conclusion, we can conclude that only alkane can rotate to form different conformations, while alkene and alkyne cannot rotate due to the pi bonds.
Chloroethene. This molecular model of chloroethene has two carbon atoms, 3 hydrogen atoms, and 1 chlorine atom. Chloroethene is a polar molecule. The bond between carbon atoms is known as double bond, whereas the other bonds are known as single bonds. After throw both models of chloroethene freely on the table, pick up both models and try to superimpose them. This indicates that both models are superimposed to each other. Thus, they are the same molecules because both models are chiral molecules, have a plane of symmetry, and have identical connectivity. Next is 1,1-dichloroethene. This molecular model of 1,1-dichloroethene has two carbon atoms, 2 hydrogen atoms, and 2 chlorine atoms. 1,1-dichloroethene is a polar molecule. It is shown that both of the molecular models are superimposed to each other. So, there is only one molecule exists for molecular formula 1,1-dichloroethene. Next is 1,2-dichloroethene. The two models that exist as 1,2-dichloroethene are cis 1,2-dichloroethene and trans 1,2-dichloroethene. For trans 1,2-dichloroethene, the molecule is non-polar molecule, while for cis 1,2-dichloroethene, the molecule exists as polar molecule. Both of the models were trying to be superimposed. From the observation, cis and trans 1,2-dichloroethene are not superimposed to each other, and there are two different molecules that represent the molecular formula 1,2-dichloroethene. This happened because of the pi bond that restricted the free rotation of the carbon-carbon double bond.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zulaika binti Zainal. Today I'm going to talk about question 3, optical isomerism of bromochlorofluoromethane, CHFClBr. So this is the two molecules model of CHFClBr where they are superimposed on one another. This yellow is chiral carbon, red is chlorine atom, and at the back is a bromine atom, and the right side is fluorine atom. So the blue one is hydrogen atom. First, I need to rotate the second model beside the first model to produce the mirror image. Whenever I rotate it at different angles, so the mirror image cannot produce. So you can see. So I cannot succeed on doing this. Next, I exchange fluorine atom and bromine atom on second model. The fluorine atom, I put it at the back, and the bromine atom, I put it at the side. Then I throw the two molecules freely and pick up to be superimposed, but you can see it cannot be superimposed. Okay. The two molecules of CHFClBr remain the different. So based on the procedure, I can say that yes, I think that there is a second different molecules for the molecular formula of CHFClBr. So that's all. Thank you.